Hello learner, welcome again to Manifested e-learning platform. In our today's lesson, we are going to start on a new topic written on the board, three-dimensional geometry. Three-dimensional geometry. So before you come to a topic, on such a topic, the learner should be familiar with solids, Pythagoras theorem, and trigonometry. Solids, Pythagoras theorem, and trigonometry, which are the prerequisite knowledge for the topic. So the objectives, by the end of this lesson, the learner should be able to state geometric properties of common solids. 2, identify projection of a line onto a plane. 3, identify skew lines. 4, calculate the length between points in three-dimensional geometry. And the last one, identify and calculate the length between two lines, a line and a plane, and also two plane. But in our today's lesson, we shall only identify what could be the meaning of one-dimensional geometry, two-dimensional geometry, and three-dimensional geometry. So in the lesson, we'll look at one, so each lesson should be having an objective. What could be the objective? So the learner should be able to identify one-dimensional geometry, two-dimensional geometry, and three-dimensional geometry in any given figure. So the learner should be able to identify that. So in such a topic, when you wake up every morning, you see things. When you talk of one-dimensional geometry, two-dimensional geometry, three-dimensional geometry, it is a description. And you only describe after seeing. In our last topic, we found out when you have a dot. Because when you create things, like this paper is constructed, you start with a point, then you move, either to create one-dimensional geometry, two-dimensional geometry, or three-dimensional geometry. So we shall look at one-dimensional geometry. So to understand these, we shall consider a point. We shall consider a point, then we move it over a fixed distance. So we consider so this is the point. You only see a point, then you move it over a distance. So when we move it over a distance, you are seeing now a line, just a line. So wherever you'll be seeing a line anywhere in a figure, that describes one-dimensional geometry. So when you start constructing, because in the topic you'll hear about a construction. A construction, you start from a dot, then you put up something. So when we have a line, it describes one-dimensional. The line AB describes, or it is in one-dimensional geometry. So a line is a typical example of one-dimensional geometry. And when you consider a line, do not only think of a line. It could be a wire. Like if I stretch a wire from that point up to the floor, that is one-dimensional geometry. You think of a wire, real life situation. We move again to two-dimensional geometry. That is two. What is that? Two-dimensional geometry. So to understand two-dimensional geometry, we shall consider a line. So the best thing to understand, consider a line. In the first case of one-dimensional geometry, we considered a point, and the point was trajected. It was moved over a distance, and we saw a line. So a line is a typical description of one-dimensional geometry. Wherever you'll be seeing a line anywhere, either in a box like this box. If I have this box, this line below here, this point to that point, that line only, that is one-dimensional geometry. So in two-dimensional geometry, consider a line A, B. That is the line. So if you move it, you land at a new point A prime. Move it, land at a new point B prime. You'll end up with an area. You'll end up with an area. So A, on moving it, you get a plane A prime, B prime. That was the fixed distance I moved. So in short, any area or plane, any area, when I talk of an area, I could be talking about the area of a triangle, area of a pentagon, area of a circle, any area you see in life, and whatever that is being built on, whatever you see an area, think of sheets of metal which are used in welding. You'll see the welder trying to cut out those sheets. That sheet you see, whether it is triangular, rectangular, it describes two-dimensional geometry, so long as it is a plane, whether you can have an area. That is two-dimensional geometry. The last one, and before you talk of that, in fact, the paper I'm holding, this paper I'm holding describes two-dimensional geometry because it has an area. It is a plane. That is two-dimensional geometry. Three-dimensional geometry. So you realize we are developing that. We developed a line, a point. We developed a point to get a line. We developed a point to get a line. We've developed a line to get a plane. So if you look at this plane only describes two-dimensional geometry. We are going to consider in three-dimensional geometry, consider a plane A, B, C, D, and move the points of the plane through a fixed distance. A fixed distance. Move the points through a fixed distance. We want to understand what will happen. So you can have the points in 3. I have a plane. So I have A, B, C, D. I'm going to move over a fixed distance. So the new point for A will be A prime, B prime, C prime, and D prime. I've moved that plane through a fixed distance. You'll end up with a solid. You'll end up with a solid similar to that box. Similar to that box. So wherever you move an area through a fixed distance, it will sweep through a volume. And that is what you get. You get a volume. So most of the solids that have volume are described in 3-dimensional geometry. So the box formed A, B, C, D, A, B, C, D, A prime, B prime, C prime, D prime describes 3-dimensional geometry. It described 3-dimensional geometry. I've used a simple example of a box. So the most of the regular solids you have are boxes, but you know there are other solids you'll meet later, like a sphere. Like a sphere. A sphere could be having a center, but it was magnified, moved through all over to have the 3-dimensional geometry. So a box describes 3-dimensional geometry. A line in the beginning described 1-dimensional geometry. A plane or an area described 2-dimensional geometry. A box formed by moving a plane through a fixed space will give 3-dimensional geometry. So all the 3 are actually seen in 3-dimensional geometry. Like in the first one, we had a line. Any line on that box will define a 1-dimensional geometry. Any plane like A, B, C, D will describe 2-dimensional geometry. But after moving that plane, the volume it sweeps through will end up with a box which describes 3-dimensional geometry. So at the end of the lesson, you should be able to describe whatever you see, if it is in 1-dimensional geometry, 2-dimensional geometry, and 3-dimensional geometry. So later you realize most of the solids you get, they'll not only be in form of a box. It could be a sphere. It could be a prism, and many more others. So at that point, I hope the learner has objectively got what we wanted here. He can be able to identify whether a given figure is in 1-dimensional geometry, 2-dimensional geometry, or 3-dimensional geometry. So before I sum up the lesson, I'll give an assignment on the same. Right, those are the figures. You'll describe whether each of them is in 1, 2, or 3 dimension. So having gotten there, I hope the descriptions were okay and you'll be able to describe them adequately. So at that point, I wish you a good time. Have a nice time tackling the solution. So bye.